Hi everyone, welcome back. So today I'm going to show you how to plot NetCDF file in Python. So if you are familiar with how to read NetCDF file, so you can easily plot that using Panoply. You can even plot using GIS. That's what I'll show you in the next tutorial. But today I'm going to show you how to plot that NetCDF file in Python. And if you want to plot that, and after that if you want to even create any animation, if you have many plots and for many time steps, so you can easily generate any GIF file as animation, and I'll show you how to do that. It's pretty simple because this is necessary to show the animations to other people, right? To even display or to present our results from our experiment, right? Or for even publishing paper or even adding to this report or presenting in front of other people, we need to even show the animations, because the general people, they may not understand what is actually happening. If you show them animation, then they will understand, okay, that is the way any storm is moving or any stream flow is flowing or anything. So you will be able to do that if you finish this video. So let me quickly show that. If you are familiar with what we did previously, so I think you already know what we are gonna do. Okay, so I'm sharing my screen here. Here is the codes. What I'm gonna do, I can show you. I just mentioned this one, right? I already know, right, how to subset a NetCDF file. And if you want to create the animation for this stereo area, you can do that. Okay, and for this one, what I'm going to do, because the storm is just covering the Atlantic Ocean, and it is generating from the middle of the Atlantic, and then it is passing and making a landfall. So I'm going to show you the entire data set, right? So in order to do that, we need to specify the boundary, the entire boundary. So if you know the boundary, or if you don't know the boundary, you can open it using Panoply quickly, and then you can get the boundary here, right? We can read that from this one. So either it is minus 97 or 95. It is 95, we can take it as 95, and here it is 50, minus 50, since it is west. And for latitude, we have that 5 degrees, right, north to 45 degree north. So that's it. So that is the idea we know, right? Longitude is from minus 50 to all the way to the 95, and it is from 5, or we can take it as 10, okay? From 10 to 45, that's it. So here is the code, nothing else. It is the same thing I'm doing. I'm importing this module data set. That's what we need. And for plotting purpose, I'm just importing that matplotlib as pyplot, right? Or PLT, whatever you need. And also I'm adding that MPL toolkits, and I need to add the base map. So that's why I'm adding the base map from that module, and I'm suppressing some warning as it is. And at the beginning, what I do this time, I'm giving the variable name NC file, and I'm reading it, right? I'm just importing the file from my directory, the same file I processed previously. It is the same name, and now I'm reading as dataset, same data. I can read it here as well. It is the same one. And next time, what I'm doing here as a next step, I'm extracting all these latitude values. This is how we read, right? If you don't have any idea how to read NetCDF file, you can go back to the previous videos where I already demonstrated how to read NetCDF file. And then I'm also extracting the longitude, and I'm just plotting, for this case, only the pressure plot, okay? So I'm just extracting the pressure variable there. And for this case, I'm extracting everything, but I'm plotting only pressure. So these are the variables I have. I have also time, because it will be time dependent. So for first time, I have to create one plot. For second one, I'll generate another plot, and I'll save it as PNG or JPEG, or means JPG, right? So whatever it is, we can do that. So these are the step where we are just reading all those variables, right, that we have. And here we have to even specify our domain, right, or the extent of our map. So for this case, I'm gonna just specify the entire domain that we have. So it is lower right corner, okay? So what will be the value of this one? So usually what we have to specify, that will be the maximum value. It is longitude is 50, right? We already mentioned that. And what will be the latitude? It is the minimum one, so that will be 10, okay? 10. And then the longitude, the minimum value, it will be 95, okay? That's it. And what will be that maximum value of latitude? It is 45, right? So that's it. and I'm keeping that resolution as I, and that is the resolution you can use. And then what I'm doing here, I'm creating a mesh grid. It is another way to, that's why we need numpy. So if you pass this latitude and longitude, it will create mesh grid. So how it works like that, right? It is going to create this mesh for you, and based on this mesh it will interpolate this data, so it will plot this way, so it will create this mesh. If you specify your latitude, all this latitude and longitude, because we have longitude values here, we have here, right, we have there, here, but we have latitude this way. It is varying from north and south direction, right? So okay, I'm clearing everything. Let's see. Okay, so I have 38 time steps, right? When you open the NetCDF file, you will see all these dimensions and property and how to do that. We already have idea about that one, so I'm just creating the list of, right, array of the time, and I'm just looping through each of these times, and okay, I'm extracting all these variables for that time step, and I'm saving that. So that is the logic here. I'm looping through the hours. I'm creating the list of hours or the array of hours here from 0 to 38, and it will, the first one will be 0, 1, 2, and all the way to 37. That means we have 38 time step. These are the integer value. We can use that value as our index as well. So here, these are the command. I'm using that C scheme, and then that MP, that map, base map, the dimension I created here, I'm passing that, and P color, and I'm passing the X, Y, and then I'm squeezing that NP, that squeeze, and I'm reading the pressure because I mentioned the variable name as pressure here, and I'm using the same thing, I, for first time step, and then all this latitude and longitude, and it will, the color map will be the jet. Okay, it will show you the changes from red to blue, and then that is the command. If you, because that is the map, base map, it will automatically download that coastline, right, for your study area. You don't need to add separately, and it will also download the state map, state boundaries as well. You can add more feature if you want, and it will also draw the countries as well. So that's what we need, and also it will show the color bar. Okay, and that is the command, and it will be showing on the right side, and 10% is the pad. And next it will increase the hour number, because we are gonna create the map for every time step, right? Initially it was 0, and I'm creating it as 1, I plus 1, so that we can get 38. There is no, because Python, it starts from 0, right? We can even specify here as well, 1 to 39, then it will be 1 to 38, and we don't need to do that I plus 1. Whatever you want, you can do both way. Why I'm gonna do that? Because I'm just trying to create that file name this way, right? So, and then it is just it will show you that title, pressure distribution of Lorentz for that hour, for 0 hour, 1 hour, 2 hour, right? So in order to do that, I'm just giving this one. Okay, so that's it. But the file, it is not for 0 hour, it is for 6 hour interval, right, from 9th September 2018. So what we have to do, we have to multiply this hour by 6. Initially it will be 6 hour from the 9th of September, that is the starting point, and then it will just multiply by 6, because the time step we have, it is for 6 hour interval, so we have to multiply that one. And I'm just specifying the limit of the color bar I specified, so that we can easily identify the pressure plot, the eyes moving, right, where the pressure is very low, you can see the red, and it will move in blue as well, right? And I'm just saving it in my C drive. I created one JPEG, that folder by this name, that folder. It will save all this files, JPEG files, and then what it will do, it will just save the file name as our number. Okay, that our first one will be 1, 2, 3 up to 38, right? So that's it. So if I run this one, let's see if it works, really works or not. I'm running the code. See, we don't have any module name this one. We have to install that module, right? This one. So how can we do that? So that is the way. You have to install pip, because when I did it in my Python. If it won't work, not a problem, we can use our Linux machine. You can use that. Okay, we may need to could not find a version that satisfied this requirement. Okay, let me install there. Sometimes you have to do that way. Okay, here I'm closing this one. I'm gonna open another command prompt. If you need to install any module, what you need to use that. Okay, pip command, pip install, and what is the name of the module? MPL toolkit. Okay, let's see. Otherwise we'll use our Linux machine, no problem. We already have that. Maybe it's not working here because the Python code, it is a 3.9 version. I installed the latest one. Maybe I don't have that one. So okay, let me quickly copy that part, and I already have, I think, the code in my Linux machine. Okay, that's it. Let me delete everything, and here it is. This is how I do all this processing in my Linux machine, not there. Okay, so here it is. I have the file name. I have the file here, the same file I uploaded there, and I'm gonna just change. Okay, let me open the file, otherwise I'll edit one and then it will plot in a different folder. So what I'm gonna do, just generate GIS. Okay, that one, image generator. At first I'm gonna generate the image I need, so I have to specify the file name. How can I do that? I have the file name there. I'm gonna rename, means I'm gonna copy it, and I'm gonna change the file name because it is in the current directory. That is the file name. It is reading this way. So far I can remember that will be 50, and that latitude, right, it was 10, and that was basically 95, and that was maybe 45, as I can remember. Everything is same because I'm using the same file. Here it will be 38 because I have 38. And what I did, JPEG, maybe I already have that here, right? See, JPEG, maybe I already have that. Where it is? Where is the file name? JPEG. Maybe I can create new, right? I don't need that one. I can create new. So it is JPEG. I'm copying at the same time. I have the folder. Everything will be inside that one. Okay. So then what I'm gonna do, I'm gonna change the name there, and everything is same. The same code I'm using here, nothing different. I'm saving the file. It is that one. But in order to run that, I have to activate the Python environment where I have installed that MPL. Okay. So that is the command. Gonna activate, and I hope that I have everything there. Let me see. And in order to run that, because I created that for NAR data, North American Regional Reanalysis, I'll show you that. No module name by this. So here I have to also install, maybe deactivate this one. Okay, so I can activate my other Python 3. Okay, this one. Okay, I think hopefully we have that. Yeah, but oh, I see we have problem there. Maybe it's showing the previous directory I just missed that one. It should be this one, or yeah. So this is how, because double dot means it is specifying one directory back, but I don't have the file there. That's why it's showing we don't have that file, one directory back. So it is in the present directory, right? And it is showing another problem that I don't have that variable name, this one. So this variable name is not that, it is the P. It is only the P, it is not that, because I stored that P variable for NAR data, not this one. So I have to specify everything. Maybe I will have other problem as well. I don't know, maybe this time it is working. Let's see if it is going to create, because it is a huge area, right? Yeah, it's creating the map. And where is JPEG? Let me show you. Yeah, maybe it is creating the map domain first. Now it is taking time, because what it is doing, it is downloading that, right? This shape files for the coastal area, coastal boundary, the state boundary, and also the country, right? Country boundaries. So that's why it is downloading and taking time. And once it's done, it will just quickly do the same step, but still it will take a while to create all this, because that's why the map is pretty big. And that's why I told you that in order to process your data, you need to make the subset. And by this time, you know, right, how to subset all this data. And if you don't know that, if you didn't watch the video, you can go back to the previous video and you can watch that. Then you will see how to subset. Once you are done with subsetting your data, then you can, yeah, the processing will be faster. So in order to, yeah, insinuate that thing, I mentioned that, okay, we need to subset our data, because we don't need the data for that is covering the entire USA, right? We need only data for our study area, because our study area may not be that much big, but this data they generate, it covers, right, pretty big area. So see the file one, it already saved. If I refresh, it will be there. And if I open it, you will see the image for the first time step. So that one, okay, that is the image. It's just coming from this side to that side. So that's the way we can go, right? And okay, so this is how we can even specify our latitude or longitude. Then we can specify everything, and then it will, yeah, it will show you everything we need, right? This is how we can plot. And yeah, even I'll show you in the next tutorial that how to make GIS when you have all this, because it will take a while. So it will take a while to see, still it is taking to plot the second one. So this is how we can plot the NetCDF file using Python code. And once you are done with your image generation, you'll have 38 right plots. For other cases, you may have more than 100. Whatever the number of images you have, you can then merge them together, and you can specify a time delay in between these two images, and it will show you the animation, GIS and animation. I have the second one as well. See, I have the second one. So it is this one. For the next one, we can't see the difference. It is moving to the shore, right? Shoreline. It is moving towards the shoreline. So this is how we can plot. And in the next tutorial, I'll show when this plotting is done. I'll use this plot to create the animation, and ultimately we'll show this animation while presenting our report or presenting our data set, right? So that's it. You can try by yourself, and if you have any different data set, like for precipitation, for the wind speed, and for pressure, and for any other spatial distribution, for temperature, or any spatially distributed data in NetCDF format, we can use Python code to plot it. And once we are done, we can even create the animation out of this images that we are gonna plot. So that's it. If you have any query or question, you can let me know, or you can try by yourself, and see you in the next tutorial. Thank you for watching, and stay safe.